Assalamualaikum and good morning. My name is MUHAMAD bin ROSLI. I will present about the objective of lab pin on this. For the first objective is to investigate the tribological properties of materials, specifically focusing on wear and actions. For the second objective is to examine the process by which operating parameters affects wear and frictions. The objective of pin on this test in laboratory setting is to evaluate the tribological properties of materials, specifically their wear and friction characteristic. This test involves sliding a stationary pin against a rotating disc under controlled conditions to stimulate real-world contact wear scenarios. Key objective include, for the first one is determining wear rate. Measure the wear rate of both the pin and the disc material. This help in understanding the durability and lifespan of the materials under study. For the second one is evaluating friction coefficient. Calculate the coefficient of friction between the pin and disc materials. This is crucial of application where low friction is desired, such as in bearing and gears. For the third one is comparing material performance. Compare the wear and friction properties of different material or surface treatments to identify the most suitable material for specific applications. Next, studying lubrication effects. Assess the impact of lubricants on reducing wear and friction. This can help in optimizing lubrication strategies for various mechanical systems. Next, understanding wear mechanism. Analyze the wear debris surface morphology to understand the underlying wear mechanism, such as adhesive, abrasive, or corrosive wear. And for the last one is testing under various conditions. Conducts tests under different loads, speeds, and environmental conditions, such as dry, lubricated, and high temperature, to stimulate different operational environment. By achieving this objective, the pin on this test provide valuable data that can be used to improve material selection, surface engineering, and lubrication strategy in mechanical design and maintenance.
Okay, for the introduction of this lab 3, the pin of this is a specific type of distributor, which is the name given to a machine or device used to form test and stimulation and wears, friction and lubrication, which are the subject of study tribology. Pin of this tribometer is a test instrument designed for precise and repeatable tribological characterization of bulk materials, coating, and lubricants. Other than that, friction and wear are characterization of material is typically performed using various types of tribometers, while pin and disc test being probably one of the most common. The popularity of the method is due to its relative simplicity and abundance of tribological context that can be well described by the simple pin of this motion. Thank you.
Bismillahirrahmanirrahim. My name is Muhammad QUSYAIRI bin ROSLI, and my metric number is B0922100017, and I will continue the presentation with methodology for experiment 1 and experiment 2. So in experiment 1, the machine was turned on. The lubricant is applied to the cap and the disc. The friction pairing is determined by inserting the pin into the holder. The loading arm is lowered until the pin is in contact with the disc. The load weight is constant at 10 Newton. and the speed is adjusted from 10 rpm to 200 rpm while taking the reading of measured friction. Next, the lubricant was changed and the weight load was changed to 20 Newton and remain constant, and the speed is adjusted from 10 rpm to 200 rpm while the friction measurement is taken. And similar for experiment 2, the step is the same as in experiment 1, but the difference is the speed is remain constant at 40 rpm and 160 rpm, and the load is adjusted and changed from 15 Newton until 40 Newton, and the measured friction for each load were taken and recorded in the lab. Thank you. Okay, I will continue the presentation of the poster with the result of the experiment. In this lab, we conduct 2 experiments. Experiment 1, which is we use a constant load and adjust the speed, and in the experiment 2, we use a constant speed and adjust the load. So in experiment 1, we use a constant load of 10 Newton and adjust the speed from 10 to 200 rpm, and using material of aluminium and brass, which is the reading of the friction is steadily decreasing for material aluminium and brass. And for the second time of the experiment 1, we use a constant load of 20 Newton and change the speed from 10 to 200 rpm. As we can see, the friction of the aluminium and the brass material is significantly decreasing, while the speed is adjusted from 10 to 200 rpm. And for the second experiment, we use a constant speed, which is 40 rpm, and adjust the load from 10 to 40 Newton. As we can see, the friction for aluminium and the brass is steadily increasing, and when we set the constant speed at 160 rpm and change the load from 15 to 40 Newton, the friction reading of the aluminium and the brass is steadily increasing when the load is steadily increasing. Thank you.
My name is WYNER William, matrix number B0922100042, and from this poster I will be presenting about the discussion of our lab findings. So in the experiment, what are the factors that affect friction? Generally there are 5. The first one is sliding velocity. So we found out during the experiment, when we increase the speed value of the machine, the friction value for both materials is consistently decreasing. And then there's a second one, surface roughness. During the experiment, we can see the roughness of one's material surface. So the findings provide evidence that it shows the surfaces of brass and aluminium are distinct. And in this trial, we can see that the aluminium material has a much more higher friction than brass. And the third one is applied load. So it conforms to the first law of Momentum, where the friction is directly proportional to the load given. So when the load is increased, the friction value of the materials also steadily increases. And the others, number 4, lubrication, and the 5th one is temperature. And next, from the discussion how speed is related to friction. So first, the force of friction between two surfaces is directly proportional to the normal force pressing the surfaces together. And the second one is the friction can act to reduce the speed or acceleration of an object in motion. That is all from me. Thank you.
In conclusion, this lab investigate friction law on brass and aluminium surface. We found that friction is affected by factors like speed, load, and surface roughness. Initially, friction decreased with increasing speed. Rougher surface, like the aluminium test here, generate more friction than smoother surface like brass. This finding suggests that material properties and surface texture play a significant role in friction.